Hi everyone. Today I would like to express my views on CFD in research perspectives. General introduction of CFDs. Computational fluid dynamics plays an important role to investigate heat transfer and fluid flow situations by using numerical methods. Turbo missions involve internal and external fluid flow problems in turbines and compressors. CFD at present is most one of the important tools to design and analyze all type of turbo machinery. The main purpose of this work is to reduce the experimental cost and time. It is used by many industries in their development work to analyze, optimize and verify the performance of designs before costly prototypes and physical tests. Research applications in CFD. They are aerodynamics, power plant, turbo machinery, chemical process engineering and biomedical engineering. Some of the research areas of CFD. They are architects to design comfortable and safe living environments, military organizations to develop weapons and estimate its damages, design of vehicles to improve the aerodynamics characteristics, chemical engineers to maximize yield from their equipment. Simulation setup for CFD. Definition of the geometry of the region interest, the computational domain. Using mesh generation, the domain will subdivide into number of smaller cells or elements or control volume. Selection of physical phenomena that needs modeling structure. Definition of fluid properties. Specification of the boundary condition. Now let us see one of the examples of CFD application, turbo machinery. In growing population, fast developing technology and the development of standard of living makes big challenge to find cheap and reliable energy. The fossil fuel are the main source for providing sufficient energy. The emission of greenhouse gases and global warming originating from fossil fuels have generated a global concern for the production of energy, leading to the increase in use of renewable energy resources that brings several advantages, which is mainly associated to the environment. The energy which is harnessed from water is the widest among other natural resources. There are several ways to obtain energy from water, in which dam is one of the most efficient way of energy generation. However, dams have huge impact on ecosystem and dam projects are expensive, especially for developing and non-developed countries. So the hydrokinetic method is the best way to obtain energy from water. Flow inside rotating passage. A turbine is a rotatory mechanical device that extracts energy from a fluid flow and heads for convenient purpose. A turbine is a part of a turbo machine that holds one moving part called rotor assembly, which is a shaft or drum with blades attached. Moving fluid acts on the blades so that they move and imparts the rotational energy to the rotor. Turbo machinery, in all devices, energy is transferred either in a continuously flowing fluid or from one or more moving blade rows. Vertical turbine simulation. The vertical axis helical bladed hydrokinetic turbine serves as a viable source of renewable power that can extract kinetic energy of free flowing water to generate the electricity. Such helical bladed turbines are characterized by lesser pulsation of torque and marginally favorable starting capability as compared to straight bladed turbines. This is vertical turbine geometry with three blades. Look at the view of geometry: bottom view, front view and right view. Spherical turbine geometry. This is velocity inlet, pressure outlet, spherical turbine and pipe. This is for spherical turbine inside the pipe domain. Here we discuss boundary conditions of the geometry. Once the geometry process completed, next move on to the meshing. The mesh consists of the basic three-dimensional elements such as tetrahedron, hexahedron, quadrilateral pyramid and triangular prism. Hexahedral element has the highest accuracy of solutions for the same number of cells on a given geometry. Various other basic elements has minimal amount of accuracy compared to the hexahedral, which is the reason why other basic three-dimensional elements are less considered while meshing process. Other basic three-dimensional elements are also considered as the degenerate of the hexahedral element, where the edges of the considered hexahedral are reduced to zero to form other basic three-dimensional elements. Hence, the meshing is concentrated as hexahedrons for entire geometry. Hexahedral mesh was used to discretize the fluid domain. For the same cell count, hexahedral meshes will give more accurate solutions, especially if the grid lines are aligned with the flow. The mesh density should be high enough to capture all relevant flow features. The mesh adjacent to the wall should be fine enough to resolve the boundary layer flow. In boundary layers, quad, hex, and prism, wedge cells are preferred over tris, tex, or pyramids. Three measures of quality: skewness, smoothness, and aspect ratio. Prism layers. Here, mesh model is used with the core volume mesh to generate orthogonal prismatic cells next to wall surfaces or boundaries. This layer of cell is necessary to improve the flow solution and provides a conformal mesh for the flow model, which helps in capturing the velocity across the boundary layer more accurately than depending on standard wall function. Computational methodology. Once the meshing process is completed, the next step is to set up the physical behavior of fluid flow. The coupled flow solver is used to solve the governing equations using K epsilon turbulence model. Rotating motions are enabled in the vertical turbine to estimate torque. Velocity profile. In this simulation, turbine should be placed in rectangular box. This is velocity inlet portion, pressure outlet. Here we are enabled rotating motion with 100 rpm. Pressure profile. Blade pressure profile. This simulation be extended to find the turbine performance by changing the blade profile as well as the helix angle at different free stream velocity. The present steady is simulated for 3-blade turbine. Further, a correlation is developed for prediction of reduction in torque and power coefficient for turbine with solidity ratio. The computational methodology is also followed by the spherical turbine simulation. Velocity profile. This is the velocity turbine of two spherical turbine. Pressure profile. Blade pressure profile. Now let us see the video. Thank you.